We are going to start with the basics for simulating with a general purpose simulation software. First of all, we can simulate lots of processes, production processes, service processes, even processes like planes arriving at an airport, transactions being attended in a computer server. We are going to begin with the simplest of the processes, the one with one queue and one server. Example for this process will be the line for buying tickets at a movie theater, or the ordering line in a fast food establishment. In a process like this, a client arrives, waits in line until the server is free. When the server is free, the client departs the line, gets attended, releases the server, and finishes the process. Before we can simulate this process in a simulation software, we need to define two main aspects: the probabilistic behavior of the times between arrivals and the probabilistic behavior of the service time. Let's say that in the process that we want to simulate, the arrival times has a behavior of a uniform distribution with an average of 5 and a standard deviation of 1 minute, and that the service time has also a uniform probabilistic behavior with an average of 6 and a standard deviation of 3/4 of a minute. Now, let's program it in a software simulation. But let's not forget that a simulation process has an entity that arrives at the system, gets in line, verifies if the server is unoccupied, leaves the line, is attended, frees the server, and leaves the system.
The general purpose simulation software that we are going to use, it is called GPSS World. You can find it in Minuteman software in the web. Once you've downloaded, you're going to open it and you are going to open a new model. We're going to work in this white area, and we need to remember that we are going to simulate the process. In this process, first of all, the client arrives. In order for the client to arrive, we need the command called generate. In the program area, we need to add a tab to add the parameters for the generate command. The first parameter is the average of the times between arrivals. If we remember the example that we were reviewing, the average for the arrival process was every 5 minutes with a standard deviation of 1. This means that the probabilistic behavior for the time between arrivals is uniform. After arriving, the client waits in a line until the server is ready to attend him. So, for the client to wait in a line, we need to create this line with the queue command. And we need to name the queue. It is said that the client waits in line until the server is ready or is unoccupied. When the server is unoccupied, what the client does is it seizes the server, and just as we did the queue, we need to name the server. Any name will work. Once the client sees the server, he can depart the line. We need to use the same name that we put on the queue command. With the server being seized and the client departing the line, now the client can be attended by the server. The command that we are going to use for this attention time, it's going to be called advance. And just as the generate command, it needs an average for the attention time and a standard deviation for it as well. Let's say that the attention time has an average of 6 minutes and a standard deviation of half a minute, or 0.75. Once the attention is ended, the client releases the server and terminates the process. I'm going to save this file and I'm going to name it example number 1. Any name will work. Now we have a saved file and we go to the command window and we create a simulation. As the model is ready, we return to the command window and we use the start command. The start command means that the number that we are going to put right here is going to be the number of transactions that are going to finish the process before the simulations ends. So if I put 50 or 100, this means that 100 clients are going to finish the process before the simulations ends. I'm going to leave it in 100 and I'm going to click OK. This that we are seeing is the report of results. At this time, I'm just going to briefly explain some items in this report. First of all, the end time. The end time is the amount of time that it would have took the system to finish 100 clients. As the units that we are using, the time units that we are using are minutes, it took the system 608 minutes with a fraction of 40% of a minute. to finish 100 clients. Another item that is of importance is how did the server behave. In this case, we can say that the server was occupied 99.1% of the simulation time, with an average time of attention of almost 6 minutes, the same amount of minutes that we put on the advanced command. We can also see how the queue or the line behave during the simulation. This line had an average count of 9.4 clients at every time, and each one of the clients took 47.317 minutes in line. That was the amount of time that they spent waiting in line. With this in consideration, we are going to stop the explanation right here, and later we are going to explain other processes more complex and with a lot of things to analyze. But for our first example, it's okay to leave it right here.